Welcome to Module 2. This is the first video of Module 2 where we will be going through some of the vocabulary, notation, and big ideas. At the top, again, you have your vocab and notation and big ideas outlined. We're going to jump right down here and discuss some of the big ideas. The first item is statistical significance. So statistical significance is a word we're going to use when we create a chance model and we discover that our statistic is unusual or unexpected in that chance model. So what it says here is, given a set of assumptions, an event is statistically significant if it's unlikely to occur by random chance under that set of assumptions. So remember, when we create a chance model, we create that dot plot with the simulator. It gives us a picture of what those sample statistics would look like if our assumption about the parameter were true. So the chance model is showing us what we should expect from statistics, given that assumption about the parameter is true. Once we create that, then you look at your statistic and you ask yourself, is that statistic a normal, usual, expected sort of thing to get under the chance model? In which case, that chance model assumption seems plausible. Or is your statistic unusually high or unusually low in the chance model? In which case we say we have statistically significant evidence against that assumption we made. So we'll come back to that and see that in some examples in the next video. Next, what we're using, according to your textbook, is what they're referring to as the 3S strategy. 3 S's are statistic, simulate, and strength of evidence. We already did this back in Module 1. We went through this 3S strategy. Here in Module 2, we're just going to make it a little more obvious that these are the 3 steps we're taking. Always at the beginning of one of these problems, we have an observed statistic. So you want to identify, all right, here's the statistic we observed. We either observed this p-hat or we observed this x-bar. So you identify your statistic that was observed. Next thing you do is you simulate. This is a step where you're creating a chance model based on a set of assumptions. Your assumption will be, my parameter is equal to such and such. So you make an assumption like pi is equal to 30%, or you make an assumption like mu is equal to 270. And then you build a chance model based on that. The chance model shows you what the sample statistics should look like if that chance model parameter assumption is true. Lastly, you evaluate strength of evidence. You look at your chance model and you figure out, where does my statistic fall on this chance model? You ask, is my statistic unlikely under this chance model, or is my statistic likely under this chance model? If your statistic is unlikely in the chance model, then you have statistically significant evidence against your chance model assumption. If your statistic is likely, if it's a usual and expected sort of thing to get under your chance model assumption, then you conclude that your assumption about the parameter is plausible. Again, we're going to come back and look at all of this in examples in the next videos. The next thing we want to think about here, and you're probably going to devote a bunch of time to this in your computer practice, is writing null and alternative hypotheses. So remember, the 3S strategy says you find a statistic, you have an observed statistic from your sample, and the next thing you do is you create a simulation chance model based on an assumption. The null and alternative hypothesis is your assumption step. The null hypothesis, written capital H subscript 0, the null hypothesis, H sub 0, what that is your assumption about the parameter. Your null hypothesis is your assumption about the value of the parameter. You assume this is true and you build a chance model based on that assumption. It's the by chance alone explanation. It always has an equal sign. So at the beginning of your simulation step, you say, all right, let's assume pi is equal to 30%, or let's assume mu is equal to 270. You assume the parameter equals something, and then you build a chance model based on that. It will show you what the sample statistics should look like if that assumption about the parameter is true. So I have some examples written down here about how you'll actually go about writing a null hypothesis. Always, when you write a null hypothesis, the way you write it in symbols is like this. You write capital H sub 0 colon, which is read, the null hypothesis is as follows. Then you write the symbol for the parameter. This will be either pi or mu for the bulk of the semester. And you then write equals whatever value you're assuming. For example, the null hypothesis is as follows. Pi equals 0.8. The way you'd say that in words is, the null hypothesis is as follows. The proportion of success in the population is 80%. Another example, in symbols, we might say, the null hypothesis is as follows. Mu is equal to 13.2. The null hypothesis is as follows. The population mean is 13.2. So in symbols is the one over on the left, and in words over here on the right. Now, actually, when you actually write it in words, you'll actually say it in context. Like you'll talk about percentage of Skittles or the mean GPA and so forth. So we'll do that again when we get down to the examples. So the null hypothesis is the hypothesis with an equal sign. It is the thing you're assuming is true in order to build your chance model. You're also going to have what's called an alternative hypothesis. The alternative hypothesis is basically the opposite of the null hypothesis. It is the other thing that could be true. Remember, we're going through all this to try to figure out, does this null hypothesis assumption about the parameters seem like it's correct and true, or is it wrong? The alternative hypothesis is kind of the other explanation. Like the null hypothesis is wrong. This is actually the opposite of that, and this is what seems more true. So the alternative hypothesis is the opposite of the null. At the end of the problem, you're either going to say, yeah, the null seems plausible, or the alternative seems more true. So the alternative hypothesis will not have an equal sign. The alternative hypothesis will always have either a less than symbol, or a greater than symbol, or a not equal to symbol. It's going to say pretty much exactly the same thing as the null hypothesis said, but just opposite. So let's jump down here. So up here in the null hypothesis, in the previous example, we had said the null hypothesis is as follows. Pi is equal to 0.8. The alternative in that case might be, no, it's not equal to 0.8. The alternative hypothesis is as follows. Pi is less than 0.8. So we would say the alternative hypothesis is as follows. The proportion of success in the population is less than 80%. It might have been that the null hypothesis was that mu equals 13.2. So the alternative might be then that mu is actually greater than 13.2. Please note, how do you figure out if it's less than or greater than or not equal to for your alternative? The way you figure that out is from your actual research question. Your research question would have originally posed a problem like, you know, my friend said that Skittles are 40% red, but I actually think there's less than 40% red. So you would be testing whether they're equal to 40% in the null hypothesis or whether they're less than 40% in the alternative. And another way to say it, maybe your friend says the GPA of students is 2.7, and you actually think it's not 2.7. You don't know what it is, but you're pretty sure it's not 2.7. So in that case, the alternative would be that mu is equal to 2.7. The alternative would be that it's not 2.7. You don't know what it is. You just don't think it's 2.7. So you'd use a not equal to in that case. So you figure out if it's less than or greater than or not equal to based on the research question. I want you guys to read about the plausible versus definitely true in the reading here on your lecture guide, and I want you to read about plausible versus possible. I've written out some details about how you should phrase things at the end of this here, and you can read about that.